Okay, we're going to talk about Redis and beyond caching, and I'm going to get my great friends from Alliance Data and Gap to do most of the talking, and so I'm going to MC it. But I'll give you some little history. How many of you guys are using Redis at the moment? I love you all. That's the most awesome thing I've seen for a long time. Okay, so a lot of this you will already know, but we'll talk about the Redis, we'll talk about these guys' use cases, and then we'll talk about Redis for modern data use cases. So what is the history of Redis? Redis has been going about 11 years. Started in 2009 by Salvatore Sanfilippo in Sicily, so don't mess with him. And he built this thing to solve a particular problem that he was having with a use case where he needed to ensure state was held across all these different application servers. He wanted super fast access, and he wanted something that kind of fit his mental model of how a database should work. And he liked things like hashes and lists and sets and sorted sets. He didn't want to write in documents and do object relational mapping. He just wanted to have data structures that he knew and loved. And that's kind of the basic core of Redis. And it's developed over time, and Redis modules were introduced in about 2017, which further extended the capability of Redis. We hit 1 billion downloads on Docker Hub in about 2018. You know, 1 billion with a B, that's pretty awesome. And then we keep on winning the most loved database. And so if you look at the most launched in Docker Hub, 5.3 million Redis launches a day. The most loved database on AWS. And you know, every year Stack Overflow goes and does a poll for developers, and they tell Stack Overflow which technologies they love using. 3 years running, it's been Redis. So we think everybody likes using it, and it's super loved. Why do people use it? Well, you know the answer to this. If you've got a fixed processing window, for example, 100 milliseconds, by the time you've got from the request that's come in through your application server, you have almost no time left to actually talk to the database, probably less than a millisecond. And so the only thing that can actually service data in that time is Redis. So why do you use Redis? Because you want to go super awesomely fast. Why do you want to go super awesomely fast? Because you love your customers. Because you want to give them the best response time in the application you're building, or your services need to respond as quickly as possible and as reliably as possible. And so at this point, I'd like to invite Brandon on to come and talk about what Alliance Data does. Welcome on board, sir.
Thank you. So I'm Brandon Mahoney. I'm with Alliance Data from Columbus, Ohio. I'm the enterprise architect of the digital area for Alliance Data. So I'm going to give you a little bit of an introduction to what Alliance Data does and who we are. Probably pretty sure most of you probably never heard of them. The problem we were faced with and the solution that we came up with to solve that problem. And then what were our really business results after we installed that solution. So Alliance Data is a company that is a B2B2C type model. We have 365 brands that we partner with. Those brands are retail stores, or we'll get into that in just a second. But basically, we offer a credit program from end to end. Everything from authorizations, transactions, we hold the debt, acquisition, call centers, self-servicing apps, you name it, of a credit card program. That's our offering to our client. And because we get all that data back, of SKU level data that they actually purchased, we can run very unique marketing and loyalty programs for our clients. So this is a slide of just a sample of some of our more notable clients that we partner with. As you can see here, a lot are retail based. That's where our roots kind of came from. But we are branching out into other verticals like gas and e-commerce, grocery, automotive. About anywhere you can use a credit card, we've got a program running. So what was our kind of current state when we looked at Redis, or why we needed it? So we're using a content management system called SDL Tridion. It's our enterprise content hub for all of our digital content. So there's millions of pieces of individual content, everything from sentences of fragments of marketing spots to our self-service web applications, you name it, images, they're all kind of stored off in this system. So kind of the challenges behind that is, how are we going to stay competitive in the market with fintechs and startups coming out that were, maybe not offering the full end-to-end solution, but they were bringing capabilities to the industry that were very innovative, and it was hard for a big corporate company to keep up with that kind of pace. So we really needed something to keep us very nimble and able to keep up with that kind of pace of change. So from a content management perspective, we really needed a very high-performance, scalable, and stable system to get all of our brand content out there for all of these different brands as fast as possible so we could keep up with the industry. So what we really came up with at that point was moving from more of a monolithic application architecture over to more of a microservices, very independent-focused architecture. So we'll bore you with a little bit of details about a content management system, but basically you have your content stored in a UI that the business users will interact with, that has all their content in a raw form. As they go through their governance processes and workflows and set it to be published live, there's now publishing microservices that look for those jobs, pick them up, and actually bring together all the different pieces that are needed to build that package of whatever they're trying to publish. Once it gets all of those pieces combined together, it will then move it over to another service, which is the deployer. That piece basically looks at all the different pieces and says, okay, this is an image, go clear our CDN out of cache and move it there, or it may be just move it to the file system, or a database where content as a service applications can serve the content out to our web applications. So we needed a lot of scalability here because we were publishing a lot of information. So there's a lot of instances of those deployers and publishers running. So we really needed a glue that was very fast-paced, that could keep all of these different servers communicated together and really, all working toward the same goal as the package was moving across the servers. So what we ended up with was we needed a publishing queue to keep all of the information flowing freely from server to server. We used ActiveMQ for that, and then Redis is the store for that data as it's moving through the servers. So basically what we had to have was a very fast, nimble way to store a package of information as it's being transported between the servers. File system was what we used in the past, but it just wasn't fast enough. By the time you wrote it to the file system and picked it back up in the next server, you were really kind of taking too much time, and some of the servers were waiting for it. So what did we really get out of this new architecture? So like I said, we're publishing quite a bit, so about 200,000 publishing transactions per hour. Those transactions are anything from maybe just a snippet of marketing content all the way up to maybe full web pages for a self-service application. So what is Redis doing with all that as it goes through? There's about 1,000 ops per second. Its incoming traffic is roughly 40 kilobytes a second on average, and outgoing about a megasecond. So other benefits that we really saw with the Redis implementation we went with, we have a 2 data center model. So what we needed was high availability out of this. So Redis was keen to delivering that for us. So we have a 3-node cluster in each data center, which gives us automatic failover within a data center as well as across data centers. The other key thing of this was we were able to break down into independent functions to where we could scale our web application servers. There's around 200 in each data center, but we were able to keep our footprint of Redis pretty low to be able to support that. but we can scale each independently as needed. So why were we going with Redis Enterprise? They take care of us. It's top-notch support. They're constantly partnering with us of how are you getting the most out of your product? Are you getting the most value out of it? Is there anything we need to do? Everything from initial startup to where we are today. Fewer resources and lower overhead. So we basically set it up and forgot about it, which means our OpEx is just the server running it. We're not having to pay someone to constantly monitor and patch it and the whole 9 yards there. Simple, seamless, scalable clustering. So most of you guys have raised your hand, so you understand this, but with Redis, it's simply just check boxes as you're setting it up. So what we saw here was it was so simple that we just check a few boxes, and out of the box it was up and running. Compared to a lot of infrastructure in the past, we had to do a lot of different configurations to get it as scalable and operational as it is today. So the key problem that we were trying to solve was speed. So stable and very performant environment, and Redis fits that bill perfectly. So what did we really get as we rolled this out? As we put the whole new infrastructure in place, we're looking at 4 times the throughput that we had in the past. The number's not really, super crazy like you'd see in some other slides, but when you're looking at 4 to 7 days to publish out content for a given release, when you can cut that in quartered, it's quite a bit. Another big key thing that we saw was the automatic failover helped us a lot, to where we went from about 70% uptime to 97 plus. So, a lot of the users weren't as dissatisfied with the product they were using internally to do the content updates. Made our business a lot happier. Some of the other things, speed to market. So there's 2 aspects to that. One being that the system is now faster, so we're getting our client information to production a lot faster. If they have a marketing spot they want to run, it's not something we have to wait till tomorrow to actually do. Just put it in the pipeline and let it run. The other part of that was the speed to market to actually get this up and running as a project. It's the joke of Redis that when we initially implemented this, it was an argument between Alliance Data and the Redis sales team that we wanted them to come on site and help us train and get it up and running. We knew, based off of some other products like this that we'd implemented in the past, we said, we need you to be on site for 7 days. They came back and said, nah, I'm pretty sure 2 days is all we really need. We kind of compromised in the middle and said, we'll set it for 2 days. You guys can stay longer if it's not done yet. By lunchtime the first day, we went through introductions with the team, and we had production running. At lunchtime the second day, our team of like 15 guys that were in there for training and whatnot were looking at us saying, hey, there's really nothing else we can go through. It's time for them to leave, which saved us cost right there. Plus, we were already up and running and didn't hold the project up any. So the next one, really streamlined client onboarding and easier ability to scale. So, because our cost of actually publishing this content is now a lot cheaper in manpower, we're able to look at clients that may not have been profitable enough in the past. We're now able to look at those as potential customers of ours. And ease of training. You don't really hire a Redis developer. So it's just something you tack onto your full stack developer. What we've found so far is that we can take a developer that doesn't know anything about Redis, and we can throw them in the deep end, and in a couple of days they're up and running and actually pretty much fully functional on it. So there's not a lot of overhead cost to keep your department up to speed on this. So what are we doing next? So we found the value in Redis. So we're really looking at standardizing Redis Enterprise over, we have coherence cache right now as our enterprise caching layer. So we're looking at switching that over here in some point in the future. And then all the new applications that we're designing, like we said, there's always that new capability in the financial services industry. So every one we're looking at, is there a Redis use case there that could help us get it out any faster? So that's what we got, so thanks.
Thank you, Brandon. So, what's the one thing you now know about Redis that you wish you knew before you started this project?
I think the key is just how easy it was to use and the actual manpower. Everybody always gets a piece of software, but they don't get staffing for it, right? So you bought this tool, it's nice and shiny and fancy, but we don't have the manpower to run it. It's just something we tacked onto someone else's job. It was super easy with this because the piece we tacked onto their job isn't the main part of their day. It's just something they need to know, but they don't really, their time's not eaten up by it.
Very cool, thanks so much. So I'd like to invite Junaid up, who's the Director of IT at Gap.
All right, thanks so much.
We'll talk about scaling with Redis at Gap.
Yes, yeah. Did I win this? I think so.
Maybe.
All right, good afternoon, folks. So today we're going to talk about how Gap was able to scale 100 times more with Redis Enterprise. All right, so I'll take a brief moment to go over the agenda. So we'll start with some introductions. I'll go over the international footprint for Gap, just to understand the magnitude of operations at Gap, a big retailer like Gap. Then I'll go over our journey. What were the challenges? What was the business requirement? What did we learn along the way? And all that good stuff. All right, so without further ado, hello again. I'm Junaid Fakhruddin. I'm a director of IT at Gap. I basically focus on the product architecture and engineering aspects at Gap. And the product lines that I deal with is distributed order management system. And my colleague.
So I'm Bill Hearn, and I'm a software developer at Gap. And I've been with Gap for 4 years, and I'm happy to share what we did.
Excellent. All right, can everybody hear me all right in the back? Good. I see nodding heads there. That's awesome. So Gap, as most of you guys know, is an international brand, and it has like a lot of brands that are part of the same umbrella. So just briefly, we have over 3,000 stores on an international scale and a footprint. Oh, that didn't change. How about now? Okay, good. All right, so, and I'm going to focus more towards the fulfillment operations at Gap because that's where the problem statement lies. So we offer many various programs for fulfillment. I listed out 3, but it's not limited to all 3 of them right here. So you can buy something online and ship it or pick it up from a store. You can ship an item from a store to do like some cost savings because the store is near to you. That's all internal behind the scenes for us. And then you can order in store. So something that you have, a store that you like that's close to you, you can just pick that store and then order all your products from there. So we kind of logistically move products to that store and then ship it from there or make it available for you from there. So I'm not going to drain this slide with the numbers. There's a lot over here. But in short, we have over, like, this transaction counts in millions. We have 3.2 million customers worldwide. And if you look at the permutations around, like, who's going to shop at a particular period of time, given that we are a 24/7 operation, it becomes pretty complex really quickly. So just to imagine this scenario where you need to make sure that the inventory is visible to all of our customers in real time, you have to ensure that all the logistics, all the attributes of an inventory are up to date at all times. Now, we had all of our processes running beforehand, like using batch processes and things like that. We had other ideas, how do we modernize this and how do we streamline this using the data streaming models, but we'll go over that in a bit. But in short, it's a pretty huge operation, tons of permutations of inventory visibility, and we'll focus on that because that'll land us into the problem statement. All right. So what did we strive to achieve? And what were the business requirements for us? So have any of you guys shopped at Gap or any other, can I see a show of hands? Excellent, that's really humbling. Thank you guys. Okay, so our approach was, or the business requirement was, to provide the most accurate timelines for fulfilling a customer order. And I would like you guys to take a moment to visualize this, that as you're clicking through adding certain items to your cart, at that point in time, we're constantly calculating in real time and giving you the opportunity to see when that item will be shippable to you in real time. And that's all driven by your persona. So our customers with different personas, they come in, look up our website, and then start adding items. And while they're adding items, you get like all the options for you to basically get the product delivered to you in a particular timeline that is acceptable to you. All right, so there's a lot to unpack here, and I won't do all of that, so I'll ask my colleague Bill to come over the stage and just do the rest of the nuances that are available. Thank you.
So again, I'm Bill Jaram, and I'm a developer at Gap, and we mostly work with all the inventory systems and sourcing optimizations. And to understand why this problem statement is actually a big challenge in itself, I would have to give you an idea of what we have today and what we needed to make changes in that to go to the next level. So at a very high level, Gap has built in several optimization algorithms that for any given online order, it will go and fetch the most optimum node, or nodes, depending on the order. So to do these, to run these algorithms, there are several factors goes in, like how close the node is, how big the node is, what the node has, what capabilities it have, all these kind of attributes. And these are only some of the attributes that are tied to a node. Now, to run these algorithms, there are several attributes which are not just for node related, several other factors that goes in. So a user comes in, gives a checks out their order, and these algorithms kicks in. So now if you see there's a disconnect between the user and this algorithm itself. There's a small time gap. The time gap is not big. It's not in the order of hours or so. It's in mere seconds, but seconds is too much for computers. And in real world, within moments, things change. And because these optimization algorithms take so many factors in them, a minor change in any of these numbers can make a big difference in deciding which node it is. So the bridging of this time gap, that means running these algorithms, at the same time the user is looking at the website, was very lucrative for us. But it also means that it comes with its own challenges. Now, these challenges are like performance. These algorithms, we built it so that it could be run in an asynchronous mode. But now that we want to run it in a synchronous mode, we cannot wait for these algorithms to work on their own pace. A user is waiting on the end of the UI for a response. We need a quick turnaround. The SLAs must be aggressive for these APIs that we were going to build. So when we started looking at where we can speed up things, try to look at all the bottlenecks, that was a challenge in itself because these applications were built for close to a decade or so. So that means these are all big monoliths talking to another big monoliths, and they are talking in really non-standard integration patterns. So with all these challenges, we have to figure out what can we do and where we can do. And now these systems that we work on, these inventory systems, lie in the middle of critical path of all the product flow. So our upstream and downstream systems, their data integrity, everything relies on my system to be properly doing what they're supposed to do. So we did look at all these characteristics that we need on the new API, whether we rebuild it from scratch or we make changes to the existing ones. It has to be seamless, smooth transition cutover, and we had a very aggressive delivery timeline. So we came up with several execution plans. We looked at them, see all the trade-offs, and we decided we will go with something like this. So we said we will split all the reads and writes. All the writes goes to our existing database, goes and writes it, and every change that happens, create, update, delete, anything, we will stream it to a new database. So now this new database, we created it such that these are all read optimized. Every change that goes in, we will make it so that it's quick to search, to fetch a single document, or to fetch multiple. Whatever the case may be, the access pattern, based on that, we made it read optimized. And this new database, we built it on Redis Enterprise. And the read optimized, the fast search part, I rely for that on the Redis search module. So I create all these secondary indexes using that module. I fetch, search, aggregate, do all of these using that module. It makes my client app really simple and easy because it's all transparent for it. It doesn't know what's going on behind the scenes. It doesn't need to do all those things on my client API. So we did implement this, and we did put a flag on it saying that it will let me control what I'm streaming to this new database and when I'm streaming it. And because, as I said before, this is a critical path system, we needed to run very rigorous and repetitive tests on it. So I would turn on the flag, let the data stream, collect their metrics, analyze it, and then repeat it again. So from all the times we did turn on the flag and collect metrics, we did see some, collect some metrics, and that's something like this. So if you see all the operations, all the relevant operations, meaning the writes, the reads, the search, aggregations, sometimes depending on the use case, it happens, combination of these. So we saw that there were around 25,000 operations per second. And you see the jump because that's when I turn on the flag, collected some metrics, and turn it off. So most of them, most of the times when I do this analysis, we would see that on average, all these operations would be under 3 milliseconds. Now, out of these operations, if I split all the records that were write operations, this is where I was streaming. This was also crucial for us because of these two database, we don't want them to be out of sync for too long because all our writes, all our reads were happening on this new database. And because we were intending it to run all these algorithms real time, we wanted it to be as close synced to the writes. So the down graph that you see is we were writing about 10,000 writes per second, and all of them were under 1 millisecond on average. Now, these were the latencies on the database side. Now, once we moved all the reads from Redis, our application itself saw an improvement, about 100 times improvement, just for the searching of all the inventories and stuff. And the write part, we saw around 40 times improvement of our legacy apps. And with all these, we are still in the process of migrating all the data, and we're still doing all this repetitive regression testing. And till now, we are seeing good numbers. And I will ask Junaid to come back here and take it over.
All right, thank you so much, Bill. This is awesome. All right, guys. So we are 100 times better now. That's thanks to Redis. And apart from the approach that we took, the architectural approach for event sourcing and the data to a read optimizer, a fast layer, we can see that we're using we're doing a mind shift over towards how we used to approach the problem, or how we used to optimize our movement of inventory and sourcing. So with that, what we're trying to do, we flip the data model a little bit, tweaked it in a way that it's compatible with Redis Search. So we're using Redis Search in our ecosystem. And even with that module added as part of another abstraction layer over all the nodes that we have for Redis, we're still seeing a lot of performance gains, which we didn't see in a regular relational database earlier on. All right, so the good question here is why Redis Labs? Maybe too far out. But as we went through this journey of selecting a technology that's suitable for our architectural design, we looked into a few parameters. We wanted a fast layer to serve this data. And we wanted to be able to search over like millions of records really quickly, millions or billions of records pretty quickly. And we looked at like the open source offerings, like what we can maintain and manage, and we looked at for our enterprise offering for Redis. Redis Labs checked all the boxes for us. The most important ones we have listed here for high availability, the architecture, it comes out of the box for you. So you can do all of that with open source Redis too, but it takes a lot of plumbing work. It is a very pluggable ecosystem. We have different modules loaded into Redis seamlessly. Redis Search is one of the components that we use heavily, where we have actually flipped our data model and used those indexes to search quickly over the results, and we get those performance gains. Apart from that, some of the other elements that are really crucial for an enterprise in terms of the operations is the business support. So that comes also out of the box. You get the flexibility of maintaining multiple databases pretty seamlessly. You have the automatic failover support, and you also get the operational insights all baked into the package. So some of the things that are really crucial to us, especially the operational insights, so that you're not flying blind into going and adopting a technology or tooling for yourself. All right, so what did we learn along the way? So we can distribute that over 4 major domains. So first off, communication. Communication is really important for an enterprise as big as Gap. We have many stakeholders that are part of a business vision. For instance, here we were looking at a personalized fulfillment offering. But in order to get a buy-in, specifically just for that one technology, wasn't enough. We had to share our vision and tell our customers or business stakeholders that how are we going to plan to phase out that approach. So it's really important for us, or was our learning for, get every one of our product architecture, product management, and the engineering teams on board early enough so that you can continue down this path. One more important thing after this is that since it's a critical path system, all of your inventory data is being moved within that ecosystem right now. Your online, your revenue, accounting, everything depends on this as part of the critical path. We have to do this very safely and do it in a way that's very durable. So at Gap, we have this product architecture group, which is combined experience of, I don't know, like maybe 100 years into this technology vertical. And they're very focused on providing or assessing like very durable solutions that is crucial for our enterprise. So we needed to get a buy-in from that. So that goes through certain reviews. We make sure that the technology is vetted out, the architecture, the whole pattern is vetted out. So all of that was part of the plan. The next important goal was to train our engineering. So everybody learns like at their own pace, and everybody has a different way of approaching certain things, especially engineers. We're very creative folk. So we want to make sure that we invested heavily into training. And we partnered with Redis Labs to do a lot of workshops and roadshows across our enterprise to get everybody onboarded to our ecosystem. So that was really crucial for us because now we have a team of engineers who know how to easily work with the technology and the tooling. We have the architectural pattern in place that can be replicated in other modules or other domains of the organization. And lastly, but most importantly, being brutally honest with your vendors in sharing your feedback. What that gives you is that as both of these companies, the vendor and the client, we're going through an innovative journey, there will be new challenges. And as long as we keep each other honest and keep each other on their toes, we're able to succeed together. So that was one of the most beneficial things that we saw out of Redis Labs as our partners. All right, and lastly, it's not over yet. So we're taking baby steps towards getting to our end goal. This is first cut of the problem statement that we went through, and this is our journey. We are a 24/7 operation, and our requirement to produce the most up-to-date inventory and the most accurate, in its most accurate and the most timeliness form is crucial for us, regardless of whichever product basically deals with our platform. What's next on our horizon for us is disaster recovery, failover configuration that we are working on right now. And it seems like pretty straightforward, but our ecosystem is spread across like a hybrid cloud model. So we have to make sure that everything's ticked and tied and we have the right approach towards BCP and disaster recovery. Now, what's desirable from Redis? Since we're using Redis Search, we're actually experimenting with an active-active configuration. And what we're trying to figure out is that what would be the most appropriate approach for having 2 multi-master configurations that can have real-time index updates for Redis Search. And with that, thank you so much. We'll conclude our presentation.
Thank you, Junaid. So So Junaid and Bill, I'll ask you the same question. What's the one thing you would like to have known about Redis now before you'd started the project?
Oh, so the best thing actually is the seamlessness of the technology itself. So it's easy to onboard engineers, which we were struggling with. It was like open source Redis. There were some parties that they wanted to work on that, but when we unpacked it a little bit, unpacked the problem a little bit, and we introduced other architectural patterns for high availability, so that made it really apparent for most of our engineers to see that, yes, there's a lot of value in it. And you can search through keys seamlessly across like many clusters. So that was a big learning for us. And it unlocked a lot of opportunities for us that we were able to play around with other modules as well using Redis Search. So and the whole abstraction makes the development of code pretty seamless and simple to us to do.
Very good. Bill?
It's kind of similar. During this whole implementation, I had to go through several rounds of creating new databases, spawning another one, migrating the data. So I didn't realize it would be so much easier. And also when I have two different, I spin up another one and I have a different set of schemas and everything going in, and things started to break out there, I would get immediate support over that, like seeing why it's breaking out. And it was easier for me to fall back and go forward. So I didn't think it would be as easy as it turned out to be.
Very good, thank you. Okay, so we've talked about a couple of cases of how these guys are using Redis and Redis Enterprise to solve key critical business problems, and how you've used Redis as a cache. And you're thinking about how to use Redis as a primary database going forward. So let's kind of think about Redis in the future, or how it's going to start evolving. You've probably looked at DB engines, and this is just a graph out of DB engines that shows the popularity of various different data models. You can see time series, graph, key value, search engines, and so on and so forth. And so it's really interesting to, if you wind the clock back 15, maybe 20 years ago, relational databases were still pretty new, and we put all of our data into relational databases. But we did figure out that that probably wasn't a great idea. Relational databases have got some great characteristics, but sometimes you need to look at data in different ways. And there's the technologies have expanded, so there's lots of specialized ways to now manage and manipulate that data. And those are just some critical ways of doing it. What we've been doing in Redis is to extend the sort of core notion of what Redis is. So most people are familiar with the core data structures: lists, hashes, sorted sets. What we've been doing with Redis is to extend it to allow it to encompass many more use cases. The Gap is a great example of being able to use full text search, and this is where the Redis search module comes in. And so we do everything from streams, graphs, time series, Bloom, JSON, and so on and so forth. These are just additional ways of looking at your data, manipulating that data, but all preserving the core characteristics you like of Redis. What do you like about Redis? It's really, really, really fast. It's very easy to scale. And that means that you can unlock new value to the business because you can access much more data much more quickly, and you can now look at that data in many, many different ways. So let's dive into a couple of these. So let's have a look at streams. So I'm sure you've all been using RabbitMQ or MQ series or Kafka. There's a million different ways of consuming and creating streams of data. We added streams into the core Redis in Redis 5. And the goal was to have those characteristics that you liked about streaming, but also at the performance of Redis. And so typical kind of use cases you'll see as message brokers or change data capture or event sourcing, because there's key features inside the streams that allow you to do things like consumer groups, have a capped collection of a stream, i.e. a scrolling window through your stream of data, and be able to actually manipulate and remove data in that stream. Again, this is kind of with all the scalability of Redis built in. So you want to consume a huge stream of data like in IoT or events that have been generated out of systems. You want to be able to, A, consume those and then be able to process those at the rate. So that's one way we've extended Redis. As the guys at GAT were just talking about, Redis Search is a full-text search engine, right? So if you want to search a product catalog, well, you could use a full-text search engine like Elasticsearch and load the data up to there, and you'd have some propagation delays as data was loaded and manipulated. You could use native Redis. You could build sets to build those kind of tree structures. And we saw an awful lot of our customers were spending a lot of time building Redis data structures in order to do full-text search. So you build a full-text search engine that allows you to consume those documents, to be able to put in stop words and all the other things you'd expect in a full-text search engine. But also allows you to do things like geospatial queries on full-text search documents. You can do range queries. And so it's much more than just being able to search text. You can actually do a whole bunch of sophisticated queries on those data. And so we often see people use this to do fast inventory searches, which is kind of what you guys are doing. But any case where you've got a lot of data, textual data that you want to look at and manipulate quickly, Redis Search is great. I was talking to a customer yesterday. They use it for autocomplete. And so they do a travel booking site, and they use the autocomplete to get instant responses for types of things that you're typing in a search box. So there's a lot of great things that you can do with the search feature. And at some point, I think today my voice is going to finally break down and die. So the problem of a conference like this, you spend 4 days talking to people, right? Okay, and one last module we'll look at is Bloom. So often is the case that you want to do some, you want to look at data, you want to look at predictability of that data. And so often we'll see people who are doing authentication or leaderboards in games or doing ad serving. They want to take advantage of things like Bloom filters or top K in order to do statistical analysis of that data, in order to actually find those patterns within it, in order to actually promote particular use cases. So these are just sort of 3 examples of how the core Redis has been extended to support further use cases. But the key capability for all of these is the speed at which we do this. So every time we look at a new type of data structure, what we do is we look at the implementation and then we compare it with the best in class. And so we are constantly benchmarking, and so when we look at streams, we can do it 500x faster than the best streaming solution. When we look at graph, when we look at JSON, we always look with this kind of lens of how fast we can serve the data. What is the average latency that we can do? How many operations per second? And so when you're using Redis for these particular use cases, you're going to be guaranteed to get a very fast and very optimal solution. And so this is sort of part of a bigger transition that's happening in Redis. So if we start on the left-hand side, here are all the core data structures you know and love. We just talked about the modules, and this is the way that the modules are extending the data structures that you can use Redis for. What we've been quietly and diligently doing over the last 6-7 years is adding all the features that help support the availability that a business needs, the latency the business needs, the persistence the database a business needs. And so you can see all these kind of core features along the bottom through backup and restore, durability, geo-replication, memory tiering. These are all features that we're adding in to allow enterprises to be more successful and to be able to use Redis not only as a cache, but as a primary database. And we have many, many customers where their data now only exists in Redis. It's not stored in a secondary database like an Oracle or a DB2 or a MySQL. It's in Redis, and it's only in Redis. And for people who've been using Redis a long time, this could seem quite alarming because most people think of Redis as purely as a cache. And what I'm trying to tell you today is life has moved on. Redis is now a fully fledged database. So let's dive into some of these features. So geo-distribution. This is one of my favorite features in Redis Enterprise. And so what is the problem we're trying to solve? Well, many of our customers came to us and said, look, we love our data in Redis, but we've got multiple data centers. We've got multiple regions. And what we want to ensure is that if data changes in one of those data centers or one of those regions, that the data is kept synchronized. And so if you use a synchronous solution where every write has to be guaranteed to be in every place, then you get a very slow product. So we did a ton of research. We worked with a whole bunch of university professors, and we used something called CRDTs, or conflict-free data types. And what this allows us to do is it allows us to, in each one of these data centers or geographies, accept writes. Those two writes can occur in parallel, and using CRDTs, we can then coalesce to a single correct value across both of those. And the nature of Redis has allowed us to do this really fast, because by each data type, we can actually put different rules in place to see how those data types get resolved, right? A string will get resolved differently to a counter, to a hash, to a list, and so on and so forth. So this is great for disaster recovery, because it means that if you lose a data center, you know the data is already in the other data center and it's already writable. So that's one way that you can use active-active. One of the common ways we see is session management. And so I'm sure you'll remember the days where you're on a website, your shopping basket was super full, and then you went to check out and it went empty. Well, why did your shopping basket suddenly go empty? Well, that session state was either living on a different server and you got pinned to a different server, or that whole data center was lost and that session state wasn't replicated to the other data center. So if you now store your session data in Redis Enterprise and use active-active, then that session state is now globally replicated. You lose a data center, your session state is now there for when you reestablish that connection. So that's another way you can use active-active. The final way is for globally distributed applications, right? Sometimes you have an application where you need to be able to accept writes in the location that's closest to you. But you want to make sure that state is replicated elsewhere. So a great example of that is gaming, right? I've just purchased this widget, or I've just acquired this widget in this game. I want to write that data locally as fast as possible. I don't want to wait for a distributed write to occur. But I also want to ensure that anybody else in that game also knows I've got that widget. And so that data gets replicated through all those data centers. So here are a bunch of ways that you can use active-active, whether it's in regular commerce or kind of fun things building a multiplayer game. How does this compare to other solutions out there? There are a ton of other ways of doing this. You've got systems like Cassandra and DynamoDB that do eventual consistency. And they will coalesce the values to the same state, typically around about 100 milliseconds. Then there's technologies like Spanner, which do strong consistency, which means that you have to update all the data in every place. And so you're going to get a much longer latency, kind of 200 milliseconds, say. Where we think our CRDT solution really makes the difference is that you can do that write operation in less than a millisecond. And now you've now got a strong consistency of that data for all those other data centers as those conflicts then get resolved down the road. And so this makes this solution really, really different and very interesting for particular use cases. But we're at a cloud conference, right? Do you want to be able to do this in the cloud? I certainly do. I don't want to run anything anymore. I want to have a managed service doing this for me. And so you can get active-active in a Redis Enterprise cloud as well to solve all of these use cases. And as you go from sort of simple active-passive replication on the left-hand side, you're going to get 3 nines of availability. If If you go all the way to the right-hand side and have active-active with CRDTs, you're going to get 5 nines of availability. And this does completely change the way that you can think about how you serve data to your customers. Let's do another quick feature, tiered memory, right? Everybody thinks Redis is a cache, right? We're trying to convince you it's not, it's more than just a cache, but you think of the cost of DRAM, right? DRAM's getting cheaper. You can get a terabyte of DRAM for about $15,000, right? That's still $15,000 out of your paycheck and your bonus and whatever, somebody else's budget. And so, you know, also data is growing, right? We talked about gigabytes years ago. Now it's terabytes. Now it's moving to petabytes. We have customers with petabytes of data in Redis. And if you think about buying a petabyte of DRAM, that's really quite expensive, if you could even fit it into a chassis. And so one of the other things that we've been working on is the ability to tier data between DRAM and SSD, right? So DRAM's super fast, but expensive. SSD is still pretty fast, but it's a lot cheaper per gigabyte. And so what we can do with our Redis on Flash is to tier the data between those two pools. So the hot data is in DRAM, the colder data is in an SSD. And what this has allowed some of our customers to do is literally save 80% of their money by being able to tier data between these tiers. And so you can see here a rough graph of the cost of 1 terabyte of replicated data from a cloud service all the way through other NoSQL databases to Redis on Flash, still maintaining that 1 millisecond latency. But memory's also changing. If you saw Intel finally in May this year, announced the GA of their persistent memory. It's been in development for a zillion years. We've been a design partner with Intel, but now you've got persistent memory. And persistent memory sort of lives between DRAM and SSD. It's kind of fast like DRAM, but it's got the cost model of SSDs. So with Redis Enterprise, you can tier it between all of these different layers in the hardware so that you can get the best price, performance, and latency that you need. Okay, so why use Redis for all your applications? You know, I love the idea of that, but I think I need to convince you, right? So if we look at it from the different the personas of developer and operator, you know, developers, they want to code with data structures, right? And that's one of the things that people may fall in love with Redis. But also, you know, Redis was built by developers. It was built by Salvatore, who wanted to have something that was fast and fun for him to use. And so one of the things we've been doing is we've been adding all of these modules to extend how you can use Redis. But last month in October, we announced Redis Insight. And Redis Insight is a free tool you can download that allows you to introspect your Redis cluster, look at the keys, look at optimizations, look at the slow log, visualize data in graphs or in streams. And so you can go to the website right now, download it for free. It's always going to be for free, and it's just another way for developers to understand and look at the data inside Redis. From the operator perspective, you know, we're living in a cloud era. We're living in a hybrid cloud era. We're still going to have on-premise. People need to span both of those environments. There's cost of ownership. There's the operational burden. So, you know, Redis Enterprise solves these problems as well. Everything from serverless deployment, if you use the Redis Managed Cloud Service, the ability to use the different tiering of memory and be able to do a mixture of on-prem, cloud, in order to meet your deployment objectives. So you can deploy Redis in all of these different ways. I think the key thing, if anybody is running from an operations point of view, the ability to do 5 nines of availability is absolutely critical to maintain these sort of services, as well as be able to do linear scalability. And in a recent benchmark, we did 200 million operations a second on a cluster of 40 nodes in EC2, right? 200 million operations a second. Just kind of think what you could do with that. just think how that could change the business problem and how you solve the problem, because you can access all of that data in under 1 millisecond. And so now you can actually think about data in a very, very different way. Okay, that's all I had for you. I think we've still got a couple of minutes for some questions. Do we have any questions for our team up here? One over here. Okay, so the question is, we talked about multi-region replication. Does that work with Elastic Cache? Great question. I'll take this one. So Redis Enterprise is not Elastic Cache. If you want multi-region availability with Elastic Cache, you should find an AWS representative. But if you come to Redis Cloud, we can give you multi-region availability with 5 nines of availability. And so you would have to look at the differences of those services and those service providers to make sure they meet your particular needs.
What considerations did you take for network latency, such as firewall or any other options in your design?
So the question was what other things did you have to consider when you were looking at network latency, like firewalls, et cetera?
So from our perspective, it was pretty self-explanatory for us. Our partners at Redis pretty much gave us a run book and said, here's kind of default configurations of what we would expect you to set up. Our firewall network teams basically took that and agreed it was probably the most optimal solution, and we implemented it right out of the gate. As far as latency times, they're pretty minimal. We didn't see that as a bottleneck at this point.
We had the similar experience, so we followed the recommendations in the playbook, ran it against like our network infrastructure team. Can't talk anymore, too much party. But so we went through like the different gates and tried to figure out like what works. So for the cluster deployments, we made sure that everything's co-located together for the single region. And we wanted to put it within the bounds of the same resource group for our product. So that kind of gives you the best of both worlds, and also brings to light the security aspect of it, because that's also mission critical data for us. So yes, that's a really important consideration to have, to get your network team involved ahead of time, run the playbook with them, and then they'll be able to give you the right parameters for security and then also the network latency gates.
So I think we can probably hang around and answer some questions afterwards, because we're just coming up for the end of the time. So if you've got any other questions, please find us after the session. But with 1 minute 35 to go, I think you might want to know who's won the Millennium Falcon. Yes? Yes. Yes, all right. Who wants to pull the ticket?
I'll do it.
All right,
Just don't pull your end.
Get your tickets out.
One?
One.
All right.
All right. The winner is 045360. We have a winner.
All right.
Great.